Hello, Algebra 2 students, section 6-6 functions and their inverses. In this lesson, you're going to study two skills to determine whether the inverse of a function is considered a function or not, and how to write the algebraic rule of the inverse of a function. Take the graph of the quadratic function as introduction example to understand the inverse of a function. Guys, this blue graph is considered a function by the vertical line test. When you apply the vertical line test, you scan the blue graph with a vertical line from left to right. If the intersection is 1 point at a time, the graph is considered a function. If the intersection of the vertical line and the graph is more than 1 point, it is not a function. So by the vertical line test, the blue graph is considered a function. This is our original function. How do we get the inverse of this blue graph? By reflecting the blue graph across the line y equals x. This is the line y equals x. If you reflect this blue graph across y equals x, it gives you the red graph. The red graph by the vertical line test is not a function. If you scan this red one by a vertical line from left to right, you will find there are 2 points of intersection at the same time. So by the vertical line test, the inverse of the blue graph is not a function. So guys, in conclusion, not necessarily the inverse of a function to be a function. Sometimes it's a function, sometimes it is not. To determine whether the inverse of a function is considered a function or not a function, we apply something called the horizontal line test. What is the horizontal line test? We apply the horizontal line test on the original graph in order to determine whether its inverse is going to be a function or not a function. So remember guys, we're not applying the horizontal line test on the inverse because the inverse is not graphed yet. We're applying the horizontal line test on the original function in order to predict whether its inverse is going to be a function or not. Take this graph. We given this red graph and we need to determine whether its inverse gonna be a function or not a function. We apply the horizontal line test. So you scan the red graph by a horizontal line from down to up or from up to down. As you see guys, the intersection is always 1 point. So the inverse of this graph is expected to be a function. Take this graph. We need to determine whether the inverse of this red graph is going to be a function or not. So we're going to apply the horizontal line test. We scan the graph by a horizontal line. As you see guys, when you scan the graph, there are 2 points of intersection at the same time. So the inverse of this red graph is not expected to be a function. It's not going to be a function. This is what we call the horizontal line test. Example number 1 applies using the horizontal line test. In part A, we're going to focus on the blue graph. So please ignore the red one. Now we're focusing on the blue one. This is our original graph. And I'm asking you to determine whether the inverse of this blue graph, which is not graphed, determine whether the inverse of this blue graph is going to be a function or not. So what shall we do? We apply the horizontal line test. So let's scan the blue graph from up to down or from down to up. As you see guys, the intersection of the horizontal line and the blue graph is exactly 1 point at a time. So the inverse of the blue graph is a function. Take part B. In part B, we're going to focus on the red graph, so ignore the blue one. Remember guys, I'm not asking you to determine whether the red one is a function or not a function. I'm asking you about the inverse of the red graph. How do we figure out? By applying the horizontal line test. Let's scan the red line, the red curve, with the horizontal line. As you see guys, there are more than one point of intersection at the same time. So the inverse of the red graph, the inverse of the red relation is not gonna be a function. So my answer for the first part, the inverse is considered a function by the horizontal line test. And for part B, the inverse is not gonna be a function by the horizontal line test. Skill number 2. Skill number 2 is a very systematic skill. In this skill, you're gonna write algebraic rule for the inverse. Consider f of x equals the cube root of f of x. This is our original function. F of x equals the cube root of x plus 1. What do we need, guys? We need to write the rule of the inverse of this function. This is our job, writing rules for inverses. Step number 1. Step number 1, you replace this f of x with the variable y. Everybody knows that f of x and y are the same thing, is equal to the cube root of x plus 1. Step number 2, you switch the variables x and y together. So you make this y x equals the cube root of, and you make this xy. Okay, guys. Step number 3, you solve this equation for y. You try to isolate the variable y. This is going to be the inverse of f of x. How do I isolate something underneath a cube root? We need to undo the cube root. To undo the cube root, you need to raise both sides to the power 3, because power 3 and the cube root, they undo each other. X to the 3 on the left hand side is equal to power 3 and the cube root, they cross out each other. So y plus 1 is equal to y plus 1. Guys, one more step is left. We're trying to isolate the variable y, so minus 1 from both sides. Now we can cross out this plus 1 and this minus 1. So finally y is isolated and is equal to x cubed minus 1. The last step, replace this y with the inverse function notation. This is the inverse function notation. This is not f to the power negative 1. This is the inverse function of x is equal to x to the power 3 minus 1. So guys, the inverse of this function f of x is the inverse function equals x to the power 3 minus 1. This is how to write a rule for the inverse. Determine whether it is a function. We're talking about the inverse function. We need to determine whether this inverse function is a function or not. We're not given any graph, but everybody knows inverse function of x equals x to the power 3 minus 1. It's a cubic function. If you imagine the graph of this cubic function, it's a cubic function shifted down 1 unit. So it's something, a rough graph, something like that. So everybody knows that this graph represents a function. So the inverse function is a function. It is a function. It is a function. And state its domain and range. The domain of any cubic function is all real numbers, and the range of any cubic function is also all real numbers. Skill number 3. In skill number 3, guys, sometimes you given two functions, f of x and g of x, and you need to determine whether these two functions are inverse to each other or not. In order to verify whether f of x and g of x are inverse function or not, we're using the composition of the function. You get f of g of x if this composition is equal to x. This is condition number 1. And you get the composition g of f of x and if you find this composition is equal to x, this is condition number 2, we consider f of x and g of x are inverse function. So for any two functions to be inverse to each other, the composition f of g of x is equal to the composition g of f of x is equal to x. What if one of them is equal to x and the other one is not equal to x? The functions are not considered inverse functions. Take this example. Determine by composition whether each pair of functions are inverses. So our job is to determine whether f of x and g of x are inverse functions or not. Step number 1, we try to find the composition f of g of x. Let's find this composition. So guys, we're feeding f of x with the function g of x. So whenever we meet any x in f of x, we replace this x with g of x. So I start with 3x, so I'm gonna replace this x with g of x, 1/3 x plus 1. Remember, we have minus 1 outside. Simplify this. 3 times 1/3 x, it's x. 3 times plus 1, it's a plus 3. And we still have minus 1 outside. To simplify that, it gives you x plus 2. Guys, we don't need to continue this problem. We don't need to find the other composition g of f of x. Why? Because the first composition is not equal to x. It's x plus 2. So by definition, if this function composition is not equal to x, I don't need to find the other function composition because one of them is not equal to x, and the condition, the first function composition f of g of x has to equal x, and the second function composition g of f of x has to equal x. Since this one is not equal to x, I don't need to continue. So f and g are not inverses. Are not inverses. They are not inverse function. Another part. For x doesn't equal 1 or 0, this is a condition. We given f of x and g of x, and we need to determine by composition whether this pair of functions are inverses to each other or not. Remember guys, the definition says if f of g of x equals x and the g of f of x is also equal to x, the two functions are inverse functions, otherwise they are not. So let's start with f of g of x. Let's find the function composition f of g of x. So currently we're working in f of x and we're replacing any x we find with the g of x. So guys, it's rational function. We have 1 on the top and we have x. Remember, we're replacing this x with 1 over x plus 1. Back to f of x. 1 over x is done. 1 over x is done, and we still have minus 1, guys. If you simplify that, 1 minus 1, they cross out each other. So currently we have 1 divided by 1 over x. 1 divided by 1 over x. This is exactly the reciprocal. You can multiply by the reciprocal of this. So it's 1 times x is equal to x. So the first condition is met. Yes. The composition f of g of x is equal to x. So this is the first condition. Yeah, the first condition is okay. But this is not enough to determine whether the two functions are inverses or not. So we need to find g of f of x. We need to find the composition g of f of x. So guys, now we're working inside g of x and we're replacing any x we meet with f of x. So 1 over x is going to be the rational function 1 over this thing, 1 over x minus 1. We're working inside g of x, so this is 1 over x plus 1. So we still have plus 1. Guys, this is really annoying thing and we need to get rid of this fraction. To get rid of this fraction, we can multiply up and down by x minus 1. So you can multiply down by x minus 1 and you can multiply up by x minus 1. So if you multiply up and down by the same thing, you're doing nothing. Let's simplify that, guys. 1 times x minus 1 is x minus 1. Down we have x minus 1 and x minus 1, they cross out each other. So everything is done in this rational part, in this fractional part. We still have plus 1 is left. So guys, if you continue simplifying that, x minus 1 plus 1 simplifies x. This is perfect. So condition number 2 is met. So guys, since f of g of x is equal to g of f of x, and both of them are equal to x, then f and g are inverses. The two functions are inverse functions to each other. So guys, in example number 3, you learn how to determine whether functions are inverses or not by doing the composition f of g of x and g of f of x. Study well, practice well, and see you soon. Bye.